section that we'll be covering today is 2.1, talking about conditional statements. And a conditional statement has a statement that can be written in if-then form. If something happens, then something else happens. All right? The stuff following after the if but before the then is called the hypothesis. That's different from science. The hypothesis is, in a conditional statement, it's the information after the if but before the then. The conclusion is the information after the then. So if I said, if it's cloudy outside, then it's raining. Okay? It's a conjecture I made up. If it's cloudy outside, then it's raining. It's not always true, but the stuff after the this, the if, it's cloudy outside, is my hypotenuse. All right? The information after the then it's raining. It's raining is my conclusion. Not the word then, but it is raining is my conclusion. All right, and there's several different types. Here's another one. If it is raining, then there are clouds in the sky. All right, the stuff, if it is raining is my conclusion. There are clouds outside. Excuse me, that's my conclusion, and this is my hypotenuse. Okay, not the if and not the then. They're not included in that. Questions? So the information after the if, before the then, is my hypotenuse. Information after the then, in the rest of the sentence, is my conclusion. All right, converse just means rearranging it. So, you know how we said if it's raining, then there are clouds in the sky? We just rearranged it. Here, there are clouds in the sky, then it's raining. So now my conclusion is it's raining, and the hypotenuse is there are clouds in the sky. Just rearranging. Very good. So he's saying the converse, you just switch it. Perfect. Yes.
What does this have to do with math?
It's how you're going to prove. Like if you go into higher level math, it's how you're going to start to prove statements are true. Okay? So if you become, I'm not saying that you're going to become a mathematician, but a scientist or something that's doing higher mathematics, you need to understand the basis for proofs. Negation means to make the statement false. You take the original statement and you make it false. So if I said the original statement was, if it is raining, then there are clouds in the sky. All right, so the negation of that would be, if it is not raining. And you don't always have to use the word not, but you have to make it use the opposite. So if it says, if it's increasing, what's the opposite of increasing? Decreasing. Okay? So if it is not raining, then there is not clouds in the sky. Yes, because it's plural. All right. The inverse is negating the converse. Okay. The inverse is negating the converse. Excuse me. Sorry. The inverse is negating the original. Okay. The contrapositive is negating the converse. So when she switched it around, so first you're going to switch it, the original, and then second, negate it. So first switch the original, The hypotenuse and conclusion, you switch the order, and then you make them the negation. Usually not, but not always. Okay, equivalent statement C say that two statements are both true or both false. Okay, two statements that say the same thing differently. Okay, they're either both true or they're both false. Like this one here. If it's raining, then there are clouds in the sky. That's one way of saying it. It's an if-then statement, right? This one's not an if-then statement, but still a statement. It is raining, so there are clouds in the sky. Means the same thing, right? Is that always true or always false?
It's always false.
Excuse me, not always, but is it true or false? Okay, if it's raining, then there probably are clouds in the sky, right? Usually. They may be higher up, but there are some kind of clouds in the sky. It has rained on a sunny day. The sun can still shine through, but there is a cloud that's releasing that. It may not be a dark cloud. Yeah. Okay, rewrite the conditional statement in if-then form. Guys, rewrite it in conditional statement in if-then form. If you start off with this one, read it. 3 points are coplanar if they lie in the same plane. That's a statement. What do you think would be the hypothesis?
If they lie on the same plane.
Good. They lie on the same plane as your hypotenuse, even though it's at the end of your statement. It is if they, and you need it, what's they? Do we know what they are? So, if 3 points lie on the same line, comma, then what? They are coplanar. Now, why do you think I talked about 3 points instead of using exactly the way they had it written? Why did I not use they and use 3 points?
Because in the beginning of the sentence, if you use they, you don't know what you're talking about.
Good. So she's just using English structure, okay, grammar. If you're talking about the beginning of the sentence and you don't know what they represent, you need to tell me what it is. Very good. So part B, water freezes at a temperature below 30 degrees Fahrenheit. How do I write that in an if-then statement? Meaning the same thing. It has to mean the exact same thing, but written in an if-then statement. Okay, Jennifer?
If water freezes, then the temperature is below 32 degrees Fahrenheit.
Very good. So if water freezes, then the temperature is that good? Okay. An even number is divisible by 2. Okay?
If it's an even number, then it's divisible by 2.
So if, instead of using it, what can we use? If a number is even, and there's several ways you could have written it, then it's divisible. Is this the only way to write it?
No.
Okay, good. Because I heard several different people saying the same thing. Very good. You could say, if you have an even number, then it's divisible by 2. Fine. If a number is even, then it's divisible by 2. Meaning the same thing, written differently. Great. That one is. But the other one said, if you have an even number, then it's divisible by 2.
Is it okay if I said if a number is divisible by 2, most likely even?
That would be not the right answer. That means a different meaning. Not necessarily is that not true, but it's a different meaning than what it's asked here. Okay? All right, so inverse, converse, and contrapositive. Remember, inverse is taking your original statement and making it what? False. Converse is doing what? Converse is not negating yet. Converse is just switching around. Contrapositive is switching around and negating it. All right, so we're only going to do one of these. If the sun is shining, then we are not watching TV. First one, inverse, is what we're going to do. Inverse, we said, was just to negate it, right? So what? That'll work. If the sun is not shining, good, then we are watching TV. Very good. All right, part B says converse. Converse is what? Just switching what? Good, the original one, the hypotenuse and conclusion. So if we are not watching TV, then the sun is shining. Okay, and the contrapositive is taking the converse and negating it. So instead of if we are not watching TV, what are we doing? Okay. If we are watching TV, then the sun is not shining. Very good. Still okay with those? Just a lot of words, a lot of definitions. It's kind of what you're going to be tested on. Recognizing what's the converse, the contrapositive, the inverse. Can everybody say that back there? Okay, we're going to skip this one. Same kind of concept. It'd be great practice for you if you wanted to check some more. Some information you need to know. We've talked about them before, but we're going to be utilizing that later on. So through any 2 points, there exists exactly one line. Very good. Yeah, I remember that. A line contains at least 2 what? Points. And if 2 lines intersect, then their intersection is a point. Very good. And through any 3 blank points, there exists exactly one plane. Okay. Okay, this is postulate 8, but through any 3 blank kind of points, so it's describing 3 types of points, there exists, non-coplanar, or excuse me, non-collinear. But a good guess. All right, so through any 3 non-collinear points, there exists exactly one plane. All right, 3 points not on the same line determine a plane. Remember that? Not on mine. It might have got copied twice, but not on mine.
No, it says if the plane is at least 3. That means exactly 1.
Okay, so it's different. All right, let's look at it. A plane contains at least 3 blank points. What are they? It's backwards. It's written differently. Not collinear, but Not coplanar. Non-collinear. All right. It's written backwards. Kind of like the what?
Oh.
Kind of like the inverse.
Like the matrix.
No, not the inverse, but the converse. If 2 points lie in a plane, then the line containing them what?
Collinear.
Okay, if 2 points lie in a plane, then the line containing them,
Collinear.
neither one of those. It lies in the plane. Okay, if the points are in the plane, then the line has to also be in the plane. If two planes intersect, so you got 2 planes intersecting, their intersection is, okay, supplementary deals with angles. So let's go with something else. If 2 planes intersect, remember planes go on forever, right? Then, not a point. Midpoint, something in the center. Okay, planes. 2 planes intersect. So look at my little cube here. Remember, they keep going forever. Somebody said it. Thank you. He said vertex, and that's closer than some other people were guessing. So be nice. At least he got something that we were talking about when we were talking about figures.
I really thought it was vertex.
Well, it's okay. It is a closer guess than other people, so.
Am I supposed to be the other people?
All right, so counter example. We've talked about this before. It's an example that what? Shows your statement is false, or an example that shows either a statement or an equation that is false. So it's going to ask you, give me a counter example. Well, give me an example that shows that statement to be false. All right, so we're going to decide whether the statement is true or false. If it's false, we're going to give a counter example. All right, so in this one, a point can lie on more than 2 lines. True or false? True. So think about it. If I've got a line, remember a line is made up of 2 points, right?
Yeah.
But any 2 points, right? I could have another point over here. Is that point on more than 1 line? Okay, good. 3 lines can intersect at no more than 3 distinct points. True or false? Okay, no more than means I can only have it at 3, maximum 3. So I want to find one that goes more than 3. So give me 3 lines. Try to draw it on your paper. 3 lines. You can do it to the side. There's a little area. 3 lines that can intersect at no more than 3 distinct points. So draw me 3 lines that intersect at 4 points. Because you said it's false.
Is it a box that, like,
How do you draw? Give me 3 lines that intersect at 4 places. Y'all said it was false. Well, if you did 3 lines and you made a triangle, how many times do you intersect? Well, show me how you get the 4th one.
Square.
But you only have 3 lines. How do you make a square?
No.
The line has to be straight.
Break it. Don't make a triangle at all. Just make a square. You only have 3 lines, boy. Oh, you only have 3 lines? Oh, okay. It's true.
it's true.
You know what I mean. It's only 3 lines.
Okay, no more than means you can only have 3, 2, 1, or 0. All right? If 2 lines are coplanar on the same plane, then they intersect. True or false?
False.
You said true. If somebody says false, show me how you can make that false.
That's very true.
Okay, so everybody says it's true because they don't want to come up with a way to make it false.
Come up with a what?
Coplanar means on the same plane. So a plane, I'm drawing a plane, extends in all directions without end. And I want to come up with 2 lines, okay, that either intersect or they don't. If they intersect all the time, no matter which way I draw it, then this is true. If I can draw one where they will never intersect, then that's false.
Well, it's true.
They always intersect. Everybody agree?
Yeah.
Yes? Yes? Yes, everybody? All right, everybody says yes, but that's incorrect.
I was right. Ha.
If you have two parallel lines, they're on the same plane, are they ever going to
I
intersect?
was just about to say that, but I thought it was wrong.
What?
Oh.
I forgot everything that I was going to say it. I guess that. I'm
Look
wrong.
at it,
I'll
man.
say it. Y'all look like more
It'll wrap around the globe and then it'll intersect on the other side.
Right, but it's not a globe because the plane is a flat surface, and a globe is rounded.
Sooner or later, there's bound to be another line somewhere.
But not if they're parallel. They'll never intersect. But yeah, eventually, you're right. If there's something else, they will. All right, this is just extra examples to showing you what they are. I'm not going to go read those through you. But they are there. There's examples, little pictures. Record it. It's 2.2, 2.3, just definitions and something called biconditional statements. All right, perpendicular lines. You need to know this information. You will be tested over that in the plan. Perpendicular lines are two lines that intersect. When they intersect, they create a 90-degree angle. So if you hear the word perpendicular, you know you have a 90-degree angle. Right? If a line is perpendicular to a plane, it means the line goes inside of that plane and creates a 90 degree with the actual plane figure. So it's like this wall and the floor. Right? They create a 90-degree angle, hopefully, with each other. Biconditional statements. Biconditional statements. They use the word if and only if. Okay, biconditional statements. Remember somebody who was telling me if a right angle, or the measure of a right angle is 90 degrees, right? You could write it, if it's a right angle, then the measure is 90 degrees. You can write if it's 90 degrees, then it's a right angle, if you're talking about one angle. If an angle is 90 degrees, then it's a right angle. All right, you can write that as a biconditional statement. All right, I could say if an angle is a right angle, or excuse me, an angle is a right angle if and only if it's 90 degrees. All right?
Very true.
Okay, so if and only if is just taking a conditional statement. Okay, it's taking the converse and the original one and combine them into one statement. Okay? Biconditional statements have to be true for both of them. If they're not true for both of them, it does not work. And just something called a logical argument, we're going to be working with that in proofs. It's based on deductive reasoning, uses facts, definitions, accepted properties in a logical order. And that makes more sense when we start proving algebraic concepts and equations. You've done that before, you just haven't written it out. So example 1, decide whether each statement about the diagram is true. Explain your answer using definitions you have learned. So, the angle HLJ. That's what I'm looking for. I think I might have miswrote it. In just a second. So, we're looking at the angle HLJ. So this angle right here, which is 36 degrees. And the angle KJL, which is 54. They're complementary.
There's two J's.
No, you may need to fix them if it's on your paper and you can't read it. This should be H and this should be M. K, L, and J.
And that little mark down there, what is that?
This is a J. That's your J.
Sorry, I don't know what to see.
It's okay. Let me make it so it's a little bit more easy to see from back there. All right. So they are complementary. Whether the statement is true in this diagram. Okay. So, is 36 plus 54, what's complementary? What's complementary mean? They add up to be 90. Thank you. So does 54 and 36 add up to be 90? True or false?
True.
Right? So it's true. All right, now we're looking at lines LK, or KL, which is this line right here, and LJ. Perpendicular. What's the word perpendicular mean? They intersect and create what kind of angle? All right, did these two lines create a right angle? No, it's 36 degrees, right? And a right angle has to be 90. So that would be what? True or false? False. And right, not 90-degree angles. There's your explanation. All right, is the angle MKJ a right angle? MKJ. No, it's a straight angle, right? So false. Or it equals 180 degrees. Either way. But as long as you can explain it and determine whether it's true or false, you're using definitions to help you rationally think through things. All right, so you got our same, a little different. I changed it on this one.
Did it move by itself just now?
No, I touched it. All right, angle KJL, this is a little different picture. KJL, it's 54. Is it an acute angle, true or false?
True.
True, right? Because we know that acute angle is what?
Smaller than 90.
Smaller than 90. All right, point N, is it in the interior of KLJ? Okay, KLJ is this point right here, is in inside of it. No, right? So it's false. It's on the exterior. And as long as you're able to explain it, it's a step, okay? Now, later on, we're going to expect specific things to explain it, but that's what it is. All right, example 2. We talked about conditional statements, right, and converses. An angle is a straight angle if and only if its measure is 180 degrees. This is a biconditional statement. How do I know it's a biconditional statement? It has the words if and only if. All right? Now, it has to be true for both ways. I can read it, an angle is a straight angle if an angle is a straight angle, then its measure is 180. And I could also read, if its measure is 180, then it's a straight angle. So, conditional statements. And you can use it in the if-then form. Then, its measure is 180. Degrees. All right, and then the converse, remember switching the hypotenuse and conclusion? Instead of saying if its measure, if an angle measures, that's how I'm going to say it. I need to put an. If an angle measures 180 degrees, then it's a straight angle. Okay? You can break it apart that way. Now realize that if an angle is a straight angle, then its measure is 180. And they also tell me if an angle's measure is 180, then it's a straight angle. I can write one statement that covers both. And it's true for both. It has to be true for both. If it's only true for one, you can't write a biconditional statement. Oh, no. All right. So consider the following statement. X equals 2 if and only if 3x plus 5x equals 10x minus 2x. Is this a biconditional statement? Yes, because it has if and only if. All right, it is written as a biconditional statement. Then my question is this true? Well, okay, let's figure it out. Remember, it has to be true for both ways, right? So if I solve, put in x for those, so 3 times 2 plus 5 times 2, does it equal 10 times 2 minus 2 times 2? So that's 6 plus 10, which is 16, right? And 10 times 2 is 20. 20 minus 4 is 16. So the first way is true. But now we have to check the back way, right? We need to see if 3x plus 5x equals 10x minus 2x gives me 2, right? I just did the converse, and it's true. Or, excuse me, the conditional statement is true. Now let's check the converse. Now that was, again, let me scroll up here and look at it. 3x plus 5x equals 10x minus 2x. Do you know how to solve this for algebra? How many x's do I have on the right or left-hand side? Yeah, I have 8 x's. 3 x's plus 5x is 8. How many do I have on this side? 8x. And then if I get the x's on the same side, what do I have to do? Subtract 8x. And I get 0. And what do I get over here? Okay, now what's your answer when you have... Okay, there is a solution to this. It's called mini solutions. So do I get x equals 2? No, because that means that any solution... Okay, it's right. It's not just x equals 2. X equals 2 means that's the only solution you can get. Here, I can get any solution. So this part is actually false. So the conditional statement is true, but the converse is false. So the whole thing is what? False. False, because they both have to be true in order for it to be a true statement. That's from algebra, the many solutions. If you don't get a variable, it's either no solutions or many solutions. If your variable goes away, it gets eliminated, you either have many solutions or no solutions. No solution would be like you have 5 equals 0. Okay? It's not true. So, but 0 does equal 0. So that means that any number I came up with would work for that answer. All right, so each of the following statement is true. Write the converse. I'm going to do this really quickly. Write the converse of each statement. Decide whether the converse is true or false. If the converse is true, combine it. If it's false, we don't. What I want to do is just pick one that is true. I want to show you how to write it. So we're on example 4, and the first one is true. Let's figure it out. If the square root of x equals 1, then x equals 1. Do you know how to get rid of a square or square root? Square, right. Yeah, we're saying it. So to get rid of a square root, I square both sides. All right, 1 squared is, and square root of x squared is just x. Because the square and the square root cancel each other out. So that is true, right? Right, and the converse says that if I start off with x equals 1, and I take the square root of x, what's the square root of 1? 1. So the square root of x equals 1. That's true too, right? So that's true. And that's the converse. So I can write it in a if or a biconditional statement, right? So if the square root of x the square root of x equals 1, and you can use this, double F, if with 2 F's, and that means if and only if. You're going to see me write it as IFF because I like shorthand. That is notorious, known on the math community as if and only if. So if you see IFS, the biconditional statement, you can write it that way. It saves you some time. If and only if x equals 1. Is that okay? Okay. Okay. Anybody else need more time? I'm going to skip this one because it's just the same thing. Deductive reasoning, the logical argument, there's another definition. We've had it before. You're just going to use information that you've used, pick it out, see what you can use. This one here says, example 1, let P represent the value of x is 7. Let Q be x is less than 10. So this says, write P, then Q in words. All right? So what it means is this. If the value, so this is P, then, that's what the little arrow means, then Q, and Q is x is less than 10. Right? It's just the wording. That's math terms. They like to do shorthand. You just need to know what it represents. It's an if-then form. You write the first, then the second, whatever they tell you it represents. Is that okay? Do you need me to do one more of those? It may not be true. So here we write Q. So if what's Q? If x is less than 10, the arrow means then, the P. The value of x is 7. Okay, is the first one true?
Yes.
Yes. If the value of x is 7, is 7 less than 10?
Yes.
That's true. All right. If x is less than 10, does it have to be 7?
No.
It could be 9. Right. It could be, but it's not necessarily. So, would you have a biconditional statement?
No.
No, that could not happen because it would be false, right? All right, good. Example 2, same kind of concept. The contrapositive, fix these. The contrapositive may have a little not, so it means not Q, then P. That's what it means. So what's not Q? Q is, it is 8 p.m., so it is not 8 p.m. Then, if it is not, excuse me, then we said P, and P is my favorite just not on. Okay, same kind of concept. All right, law of detachment says this: if P, then Q is a true conditional statement. Okay, P is true, then Q should also be what?
True.
True. Okay, it should be the case. All right, let's see. One more law that I want to just introduce you to. This one says if P, then Q, and then Q, if Q, then R, are true conditional statements. So if that is true, then you can kind of do the transitive property, which means this: if P, then R. Okay? If P, then Q is true, and Q to R is true, then you can kind of Combine them, and then P, then R. Kind of like these you would use here. Right, some conditional statements can be made from the following true statements. So if a cat is the largest of all cats, then it can weigh 650 pounds. And then you notice here, if a cat weighs 650 pounds, then it is a tiger. I can do this. If a cat is the largest of all cats, then it's a tiger. Do you follow what that is?
Yeah.
Okay. That's the previous law. You can combine things. You're just leaving out the 650 pounds.
So what do we do with that? Do we just like,
You would rewrite it. Like it might ask you to use the law and combine some conditional statements.
so like,
And so I would write, if a cat is the largest of all cats, then it's the tiger.
so it would give you more than one sentence?
Yes, they would give you more than one sentence. It might be something like they give you all 5 of these, and you write one of the conditional statements.
Can you like choose any one of those?
Yes, you could have done many. Like this one, if the cat lives in a pride, then it's a lion. And then if a cat is a lion, then it weighs 400 pounds. You could have done this. Is that good? All right.